Howdy everybody in YouTube land. What we have in front of us today is a Toshiba T3100/20. Now, I've never had one of these machines. I laid claim on this one about a year ago now, a little over a year ago now, and it just now got sent to me. So anyways, we're going to explore this together because it's kind of a cool machine. It's very heavy. It's like it weighs 1,000,000,000. It's very, like, yeah, it's very heavy. But, I kind of like the design of it, but more importantly, like how the screen springs open, which, I don't like that sound. Yeah, I wonder how long ago before that snaps apart. But the two quick observations I made with this machine is the keyboard feels really nice. It's not mechanical, but it does have that feel to it. But more importantly, this actually has a plasma display assembly on it. It's got a little bit of rubbage marks, nothing too out of the ordinary. This is warped a little bit, but other than that, it's in pretty decent condition. Now, it's still a toss-up whether this plasma display actually works or not, because I've heard horror stories where a lot of these are not working properly anymore. Other than that, there's like this switch on the side here, which sets the external port to drive A, B, or printer. And it's got this cover on the side, which I think that's where a second floppy drive would go, but there's nothing installed there. But also, we have the floppy drive that's on this side, but we're missing the door and we're missing the button. So that's an issue. Maybe something can be 3D printed for this, but unfortunately, I don't have the reference files or anything for that button. So, not entirely certain what to do there. And then we have an unused hole. So, the back side of this thing, we have a warped handle. Very warped. But this handle, like, I think it comes out? I don't know. I'm not familiar. It looks like it swings. Okay, it pulls up, I think. Yeah, it does. It's got a modem in it from Multitech Systems. Serial port, printer port, random dip switches, and then an RGB output. So it looks like this thing can do CGA. And these are probably the dip switches for setting MDA, CGA, Hercules, all that stuff. Well, at least that's my guess. And it's got this big power supply. But for being a laptop, there's no provisioning for a battery. So, yeah, we have that. Now, I don't know if it works. I have no idea. There's a plastic piece or something in here rattling around because I hear it when I move this machine around. So, I want to take it apart and inspect the inside of it. Plus, I don't know exactly when this machine was made. I'm going to say late 80s, very early 90s. Which means it puts it right in that era where, you know, capacitors become a problem. So, I definitely want to get this apart. Man, I almost can't even lift it with one hand. It's that heavy. I'm trying to manipulate it so I can actually get back here with the screwdriver and take these screws out. Really? So that way I can see what we got going on inside here. Now, I don't know if this has a hard drive. I presume it does. If this Toshiba model number follows any standard that Toshiba of the newer times use, this indicates the size of the drive. So this is a 20 megabyte drive. So I think it did have a hard drive in it at one point. But I don't know. This machine came from an electronics recycler out in California. So I don't want to reveal the name of which one it is, because the last thing I want to do is, everybody like swarming them. Because one thing I've noticed with YouTubers, and especially major channels, YouTube influencers, is when they start reviewing a product or something like that, it creates a huge demand rush, which drives the prices up and the availability down, right? And I don't want to be that person. Although I kind of become that person by default. Anyways, rant mode over. Those 3 screws came out, but it's not... I probably gotta take the screws out from the bottom. I'm sure there's a service manual for this. I could go get that service manual, but I'm kind of lazy. So, yes. I do want to get into this plasma display too and see if there's any like surface mount caps or anything in there that are leaking. Because the thing is, you never know. Also, I'm sure the driver ICs for the plasma display are proprietary, and I heard that crack. So this is suffering from some form of brittle plastic disease. Because I'm not liking the cracking noise. Which means it kind of gives me an indication that this machine has never been apart before. So there's at least that. The magnetification actually likes to just demagnetize itself on this screwdriver. I keep an old hard drive magnet on the side of my thing here for magnetizing screwdrivers. Oh. So apparently there's some screws in here. So I gotta pull that handle all the way out to get to these screws. And I can see in this case where a magnetic screwdriver is absolutely mandatory. So you need to be separated into separate things so we know where they go. Those are the rear cover screws. The ones in the middle there are the front. And then these are the handle hole screws, which are there. So that's the only screws I see so far. So yes. Product of Japan, assembled in the USA, which means it was made in Japan. And they just put it together over here. That's like today when they go, yeah, you hear that noise? Yeah, I hear pieces rattling around inside. Makes me wonder if that's where this went. Wow, this thing is warped. Look at that. It's like it's been shoved in a press. I don't know if all these Toshibas do that or if that's just this particular machine, because that's like, yeah, it's fun. So I'm wondering, yeah, it's coming off. So it's stuck on this side. I'm gonna have to go. I'm gonna put the camera down so I can use both my hands. So I had to break down and look at the service manual, which it kind of tells you what's going on. It's not it's missing the memory board, but there's been some shenanigans going on in here because it's been apart before. There's a screw or ground cable that's loose, just floating around in there on the LCD panel. I don't know what that's about, but we got a bomb in here we need to remove, so we got to take care of that. But also, the keyboard, which plugs in here, was not even plugged in. It was just in there. So someone's been screwing around. Maybe they stole the memory card out. Maybe, who knows. But the hard drive is still in there. So it's not like they took it apart to get the hard drive out. Or maybe they tried and failed. Because you got to, from the way this thing is built, you got to take the LCD, or plasma panel. We got to peel this sticker up and take this whole thing apart to get the cables out, snake the cables through there so we can lift this whole. It's an asinine design, but that's how it's designed, unfortunately. So yeah, we are missing the memory card, and it's proprietary and nearly unobtainium. So we'd have to clone that, assuming the specs are available. So that's got to be done, but also, the battery's got to be replaced. We've got a couple of little caps here. I don't know if they're leaking yet or not, but more importantly, I need to figure out when this thing was made. There's some DRAM. There's a bunch of this. It's probably more RAM. So 87, 87, 88, 120 nanosecond, 1990. So yes, we've got, this is the newest date code so far, 1990. So this machine was probably made in 1990. Or, yeah, so it could be anything. Gotta check this power supply out. And this has got this funky spring-loaded thingamabob. I don't know what that's about. It's a doingy doingler. Doing, 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 doing. I'm not sure what that goes to. I'm gonna have to figure that out. Yeah, alright, so I need to start tearing this apart even more. So that explains why the button's missing, is because someone had all this apart for some reason, trying to work on it. And that, you know what, that's even more evidence, because you can see that bent in, but this pulled out. So someone's been tinkering. It's possible this floppy drive doesn't work. I don't know. We're going to find out. I mean, it was cheap. I waited around for it. It's a cool little toy to play around with, so let's make a decent video out of it. Alright, so that was painful. We got to peel the sticker off and take these two screws out. While holding it up, you got to grab a spudger tool or some plastic tool and pop the clips out around the edges. And they clip in like this, where you got to go that way with it, not this way. So finally, the surface manual is not so clear on that, but I finally got it popped loose, and then it really stinks inside this thing. And yeah, it's been left outside for a while, because look at this. You can see the corrosion and the bugs and stuff like that. So it's been stored poorly. But perhaps more importantly is these cables here are starting to delaminate. You can see it all around the edges there and here. Which now it makes sense looking at that, why some of these have lines in the displays that don't ever, you can't repair or go away. This is why. This is why. It's delaminating. So it's possible I can use a little bit of heat and try to re-adhere it, but I don't know. That's going to be a tough call. But yeah, it's just kind of molded up a little bit in here. So that's why it stinks. It stinks like mold. So it's been left outside. So next step is, in order to get this top cover off, we have to remove the panel. And we have to get the wiring loom out from underneath it so we can lift it off. Because otherwise, it will not come off. It's unfortunate. So, and then once we pull the plasma panel completely off, we have to unplug all the wires and then unscrew the hinges and remove the back plastic. And yeah, you have to disassemble the entire display in order to get this whole thing out. It's just, I don't like this design. It's a good thing it didn't really last that long. I think the 5100 was the last one, the 386 model, before they killed this entire product line. Oh yeah, listen to that crack. Yeah, that panel's never been out before. If it was, you know, it wouldn't make that cracking noise. So someone tried to take it apart without realizing you gotta take the whole panel out. I'm going to put the camera down because I want to make sure that I catch it in case it slips and falls down, because I don't want it to break. Just like that. So we're folding it down. This is that ground wire that's not connected on the bottom. Now that we got it folded down, it's very similar, if not the same, as the IBM P70. Because the IBM P70 has a 640 by 480, while this is a 640 by 400. So this can only do MDA, CGA, not really VGA. So, but yeah, it's like, yeah, these ribbons are starting to delaminate from the edge of the glass, which is why we're having problems. So it makes sense now. So these are your X position drivers, and then your Y drivers are up here. So if you got lines going this way, your issue is here. If you got lines going this way, your issue is here, right? So, but also it's very similar in design to the P70. We got the same style caps, same company, Matsushita, Panasonic. So, yeah, it's all very reminiscent of the P70. Um, Now, it uses an external high voltage power supply input, which means this power supply generates the high voltage. So we're going to have high voltage caps in there too that we're going to have to look at. But all right, so I think that's it. So let's get this thing all disassembled and out of here so we can actually work on it. It's the same company that made the P70 panel, but you can see it right here. You see it? How there's black spots where it's still bonded, but the light spots is where it's coming loose. That's the problem. Once you take all the screws out and then pop this out, which is just held in there by those, you can slide that wire out, slide that wire out. So now everything is out. There's all the screws and mounts and brackets and stuff. So this, in theory, yeah, see, the amount of pain it takes to remove this cover. I'm still worried about the delamination of the ribbons. It's possible that a hot bar from like a soldering iron or something could possibly rebond those. Otherwise, you need an ultrasonic welder, which is not something I have. I'm sure I can get one out of China because people fix OLED phone displays all the time, and it uses the exact same technology, right? Same thing with LCD. So, all right, but yeah, see, this was disconnected, so it probably went right here, and there's a screw missing. So this power supply, something's going on in here. I don't exactly know what, but yeah, this thing is kind of beefy for what it is. So let's just keep disassembling this thing, because I know there's a part rattling around inside here, which could be just a screw. I don't know. But we're missing that. I'm hoping that's in there. It may not be, but yeah. Fun stuff. Now that's a heck of a power supply. I just took the screw out here that was left. That one was missing, and then one back here, and slid the cover off. And that is a big power supply. So this is like a desktop computer that they crammed into a laptop. It's kind of interesting. But yeah, it's using these PFM series of electrolytics. I don't see any signs of leakage, but from 1988, they're getting changed anyways. These three are 250 volt caps, which I'm sure is the power rail for the plasma panel. Don't know if I have those on hand. I might have some 47s, but I don't think I've got any 33s. So I'll have to check my stash. But in the meantime, I want to start getting this out. This hard drive looks like it's like IDE or something, but I'm not entirely certain on that. So don't quote me. I need to get this out though. You can tell where someone has tried, but they didn't get very far. There's a little random card in here. I got the power supply pulled out. Modem is completely out. This one is plugged into the hard drive. So this is probably the controller card, if I were to hazard a guess. I have an itching suspicion that this is like the IDE or... Oh man. It's tighter than hell. It's never been out before. I'm the first one to take it out since this card was put in new. I'm just curious if this is like IDE or what it is, because honestly I don't know. I'm sure the manual tells me, but I have not read it. I just like figuring things out on my own. I've always been kind of nutty with that. Let's see, what do we got? No, it's Toshiba Proprietary. So yes. Oh, that connector. Well, you know what? That does not look standard IDE size, so no. This is not IE. This is something proprietary. 100% proprietary. Okay. Not surprised. Well, we have a super capacitor in there. Why we need this when we have this is beyond me. So, okay, well, yeah, this one's been all quinky-dinkulated. Someone's definitely been in here tinkering around, but I gotta figure out how this comes out. So, oh, like that. Okay, it's out. Right. So, there's something rattling around inside here. I need to find it. Oh, I just did. It's not the eject button. It's that. I don't know what that went to. It's a grounding post. It's entirely possible that was part of this at one time. I'm not sure, but that floppy drive appears to be proprietary as well, because that is not a standard 34-pin floppy connector. This hard drive is non-standard. Nothing in here is standard. So all of this stuff is indubitably proprietary. Okay, bomb removal. I guess since I don't have a RAM card in here, I can just kind of like, I don't know. But I don't really see any caps in here that need special attention at all. So, and this is unpluggable, or not unpluggable, I mean. So you have to remove the plasma panel. Yay! Okay, well, that's fine. That's the real-time clock, because that's the battery that powers the real-time clock. But then why do we have this here? That makes no sense. I'm currently inspecting the floppy drive, so this thing has been pried apart, or at least tried to be pried apart before. But more importantly, the two screws are missing on that side, but they're still there on this side, so someone's been tinkering around in here before. And then, who knows how long ago that even was. The button's missing for the eject mechanism, unfortunately, so we don't have that. And also, the floppy drive has got a proprietary cable interface, so it's not like we can put a standard PC drive in here without a modded cable. And then the hard drive is also completely proprietary, and the card that runs it is completely proprietary. And I think it might even be based off the Western Digital 1001 MFM controller, but I'm not sure. I got the floppy drive out, and it looks to be using the same chipset as those IBM PS2 floppy drives, but instead of surface mount capacitors, they've got these through-hole Elna brands in there, which I'm not seeing any signs of leaking yet. Key phrase, yet. Bipolars. There's the 3 bipolars that the typical design has, and then the standard regular ones. So I figure I'll just take this apart and check everything out and then clean it up. But that is definitely proprietary. Tell you what, this is such a cool battery. Made in Japan, 1988. Lithium. Do not incinerate, blah, blah, blah. Yeah. Away you go. So, what I've noticed is this cable that was connected into it has this 330 ohm resistor in line. And that's a 3.6 volt lithium. So that makes me wonder if I can just get a standard 3 volt 2032 battery holder, like what Mike Tech uses and everybody else uses, just get rid of this and just put some Velcro on a 2032 and just say heck with it. Because I bet that would probably work fine with this system. Anyways, I'm trying to debate here. I'm trying to think. Do I want to just plug this back in and power it up just to make sure it works before I start recapping it? Or do I just want to say the heck with it and just deal with it like it is? It's a hard decision to make because I don't want to put a whole bunch of work into recapping things if one of these chips is bad, right? So I wonder if I should just go ahead and just plug things back in loosely, turn it on, and see if it fires up and beeps and does whatever, and then recap it. Yeah, I think I'll do it that way. I'll just get all this stuff reconnected and just fire it up and see what happens. Just to make sure things are kosher. But I did look in the service manual, and this is definitely documented. This is just your standard 8-bit XT ISA slot, and this is your 16-bit extension. So this is your ISA. Now, this is the only expandability this has. None of the rest of these connectors are documented, unfortunately. Alright, so I got the power supply loosely in here. I don't see any reefers, so I think it's safe to plug in at this point. Ooh, hold on. Yeah, barely. Actually, I'm gonna unplug it from the wall. Plug it into here first. Yeah, this is just asking for it. Alright, here we go. It fired up. Hey, we got beeps. So that means the board posted. Hard drive's not spinning, but I'm not entirely unsurprised. So this drive might be toasty-o, but we'll see. But it turns on. I like that it turns on. You know what? I should plug the plasma panel in here and just kind of sit it in here and see what happens. So let's do that. Alright, so here we go. I got the LCD plugged in and it just kind of janktified setup right here. Let's see if it works. Hey, it lit up. Ooh, cleared the screen too. Holy crap. It actually works. And you know what? There's no lines. There's no dead spots in that panel at all. I got super lucky with this. That's amazing. That's luck right there. Because I've seen so many of these on the internet where there's stripes and stuff stuck in it. And this is why, that delamination. Well, I figured out where this random nut that's laying in there came from. Came from this modem. Because this one still has the nut screw on it, but that one doesn't. It came off. That explains a lot, which is why this is snapped. So, yep. Anyways, I'm going to continue getting this board out because even though I don't see any problems, I want to change this, which are, what are they, 47s and 16s. I have them on hand, so I want to change that. I'm not sure what that's for, but I kind of want to get it out of there because it's, you know, these, at least in the Xboxes, they tend to leak and cause all kinds of problems. So I want to get that out, and then there's a couple of tantalum capacitors that could short. Figure out what those are and change those out as well. And then I got one over here. But generally this board's not so bad, but I want to dump these ROMs. They may already be archived. If you look on the retro web or something like that, they're probably already archived, but I want to dump them anyways. And I want to dump this ROM as well. It just sucks that it's soldered in. But that's just the way it goes sometimes. So let's get that dumped. Let's get that dumped. I'm not sure what that's for. Probably an oscillator divider IC because there's a crystal here and then there's one up there as well. This thing's got all kinds of different clocking sources. This is probably for video because this is the video circuit because there's the memory and all of that. Now this pinout is not known. I can't find it documented anywhere. I guarantee it's in the service manual for this, which is non-existent. There's a maintenance manual, but not the actual service manual, which, yeah, and I'm pretty sure that the Toshiba 3100/20 is unique because there's a 3100E which has a complete board here and it's got 30 pin sims. So that makes it a lot better, but this one does not have that. So, oh yeah, and I gotta fix that too because it's also broken. Alright, yeah, not a big deal. It's just little things like that that I have to take care of. But in the meantime, I need to get the floppy drive back in this cage because I got my caliper out here and I want to take some measurements so I can get the button remade on a 3D printer. Now I have the motherboard removed and flipped over, and this is kind of cool. I don't know, the designers must have been proud of their work back then because look at that. That's some funky artwork. I don't know the thought process behind that, but just to learn the lore of how this was done would be quite fascinating to me. But anyway, so other than that, I'm not seeing anything out of the ordinary stand out. Just maybe where someone tack soldered that in, and a little bit of flux residue here and here. I'm assuming this is the processor direct bus, and this because this is just the RAM and ROM and keyboard controller. But this pinout is not known, and I can't find it anywhere online. So if I can find data sheets to these chips, I can kind of sort of figure that out. But the downside's going to be the row and column address strobes that are going to be here. Because we're not going to know what those are. I mean, that's not entirely accurate because these gate arrays, and one of these gate arrays is a RAM controller that runs all of this. The gate array documentation is available. So the pinout is known for each gate array. So I can actually find the gate array that's destined for the memory controller, for the DRAM controller, and document where they go over here. So I can kind of sort of document this pinout as best as I possibly can based on the gate array. Now, there is a picture in the Vintage Computer Festival forums, or Federation, I should say, the VCF forums, where someone posted a RAM card that goes to this, which has this exact memory on it, and it's got some of these chips on that card. So it's just a duplication of this with the additional address lines, or the additional row and column address strobes, which is going to come from one of these gate arrays. And that is documented. So in theory, there is enough information that I could design a new RAM card with just standard like 30 pin SIM DRAM type memory. But it's going to be interesting without knowing. Yeah, I got to reverse that pin out essentially. And I got to see if I can even get that socket anymore. And if I can't, it's going to have to come off and get replaced with something that, whatever. So, yeah, it's going to be interesting. I'll say that much. Alright, so the next order of business is replacing the capacitors, of course. So, even though it didn't show any signs of leaking on the PCB, I went ahead and removed one, and I figured I would stop and make a video because guess what? Look at that. Because as soon as I was heating this up, I heard the tss noise. And they're leaking. So, yep. They all gotta go. Yeah, I'm scrounging around for parts. I only have like 2 of these and then 1 of those. So, I'm just gonna have to make it fit. Because 47s and 33s are not a whole lot of what I deal with. I see 12,000s, 12s, 15s, and 22s most of the time. I never see these big 33s and 47s, so I don't keep them. I got some 47s. I got some 33s, but only at 16 volt, and I need a 25 volt because that one is a 25 volt. So I got to put a couple in parallel or something to make that work. I do this a lot on this channel because a lot of these machines like this one here, I own it and I don't want to stick a ton of money into it, right? So I just use what I have to make it work. And if I was doing this for a customer, I would go order the right stuff to make all this work. But since it's just for me, I don't care. I'll just put that disclaimer in right now. All right, but yes, I had to clear off all this crap because there was some corrosion from capacitor leakage that I didn't see because it was hidden up underneath the capacitor. So yes, they absolutely had to be changed. So now I am working with that. This is the most asinine way to do it, but it's the only thing I have on hand that comes even close. I could either throw a 2200 in there or I can throw a 3000 in there. So I think I'll throw a 3000 in there. Now it's just a matter of getting it to fit. So what I've done is I've bent one over and I've wrapped the leads around and soldered them in place. That way it's a good solid mechanical connection. Normally you wouldn't do it this way. You would just order the right capacitor. But these are the only things I have that are in low ESR variety. So that's what's going in there. Alright, so there we have it. I left these alone because I don't have them on hand. But I changed all of them out. Now, a couple things. I had to use these dual 1500s in parallel because I do not have a 3300 at 25 volt. But I had plenty of 4700s at 10 volt, which these are actually 16s. But these require 47s at 10. This is a 470 at 10, which I shoved a 16 in there. And then this is a 470 at 25. So that's in, or no, a 220 at 25 low impedance, so that's in there. Now there's these let's see, these were 33s at 250, which I don't have, but I do have 47s at 250, which came out of my vacuum tube capacitor stash, so those are now in there. They'll work fine. Then we've got a 47 here at 50, we got a 47 at 25, and we've got another 220 at 25 here. And that's it for all the caps. There's nothing else left. It's pretty simple and straightforward. So, good enough. Now this thing can go back together. But before it does, we've got to address any other little capacitor issues here and there that we need to just go ahead and change out while we have this thing apart. Alright, so on the motherboard, we've got 3 little low profile 47s at 16, which I have them in my stash because Sony loves to use them, so I always keep them around. So I have those that we'll use to put in there. There's a pair of 10 microfarad 16 volt tantalums, which are going to get changed as well because I don't want them shorting, because this thing is old enough to where, yeah, that could be an issue. So we'll just keep plugging along and get that taken care of. Alright, so everything's been replaced with the exception of this one. And I don't want to cause a malfunction by removing it, and I don't have one of those right now, so I'm just going to leave it at the current moment in time. But everything else is all good with this board. So the next thing I want to do is I want to take a look at the hard drive, take it apart, and see what we got going on with that, and if there's any caps in there that need addressed. That might be why it's not spinning up. So let's take a look at that. Alright, so after removing all the hardware off the hard drive with the little covers over there, take this guy, move it off, see what we see. Well, right away, let's see, we got a nice pukage going on there, we got some going on there, we got some up here. Yeah, I wonder why it doesn't work. Huh, well, that probably has a lot to do with it, why it's not spinning up. So you can see the fluid like right here. So yeah, this thing needs cleaned up, which means I gotta pull this thing apart. Well, that's just how it goes sometimes. So yep. Okay, well, gotta take care of the problem. So there's 310 microfarads here. There's a 22 here, which I think I have some. I don't remember. And then a 47. I have those. I have those. I don't know if I have those. But judging there's 3 of them here, I'm wondering if that's the driver capacitors to this head control. So This is an interesting design. I've never seen anything like that. And then the spindle motor is right here. So, alright, let's see if I can get the rest of this drive apart. I decided against removing the circuit board because it's impossible. There's too many things that go through the board. The spindle goes through it. I don't know what that is. The head actuator goes through it. There's a bunch of stuff that goes through it. You can see a screw coming through it from the other side. So, and I can't figure out how the rest of this drive actually comes out of here. It appears to be a JVC drive, but I can't tell. Now, the spindle is free, and so is this. I haven't moved it from this position because I don't want to damage the drive. And like I said, the spindle's free. So I'm just going to leave it like this. I've got these 3 capacitors replaced now. And I just got to do this 22 up here. And I got to do this 47. Alright, and there we go. So I had these on hand, these 10s at 16. So those have been replaced. The 47 at 16 has been replaced. Now this 22 I didn't have. So I had to just make do with one of these low profile caps and just solder it in there that way. Not ideal, but it will work. So I just got to hope the rest of this drive is good because it doesn't spin up. But I can't imagine why it doesn't spin up with all the leaking capacitors everywhere. I checked all these areas around for trace damage and I didn't see any. So I'm just going to leave it like that and hopefully it spins up. So I think at this point I'm not going to mess with this floppy drive right just yet. I want to get it back together and see if the drive at least spins up and everything still posts and I didn't break anything. So that's what we're going to do. I just went ahead and threw a temporary screw in here, so just so this doesn't slide around on me. So here we go. Nope. Darn. Yeah, it was worth a shot, but no spinny spin. Although it's kind of hard to tell. But I don't think that thing's spinning. Usually they're fairly loud. Well, it was worth a shot, but hey, the power supply comes on and everything still works, so I didn't blow anything up with the power supply, so that's a good sign. I found this thing online, and there is a signal that turns the motor on and off. So it's possible it's not telling the motor to come on, but I'm not entirely certain on that. Alright, so I hooked the display and keyboard up so I can get past the post screen, and it throws an error occurred initializing hard drive. So this thing's not spinning up. So the motor controller on this drive is dead. Why, I don't know yet, but it's definitely a goner. So who knows? So it's basically done, I think. But I'm going to try to get this thing out of the enclosure and get it apart and try to see if I can find out what's going on. Maybe it's a drive IC. Maybe it's, who knows? We'll find out. Now this keyboard, like I said, it doesn't feel mechanical, but then again, I don't know entirely. So I just flipped it over and just looked at it. It's an Alps. So this is indeed a mechanical keyboard. It just doesn't have that clicky feel to it, I guess is the proper term to it. But it still types nice anyways, so alright. The problem we have now is this stupid hard drive. We've got to figure out what's going on with it. Well, it's junk anyways. We ain't got nothing to lose, so we might as well just take it apart. Now, this has got to be the world's thinnest MFM hard drive, because that's just insane. But it looks like you have to take it apart from the bottom. So this whole board comes out with the platters and all. That's painful, because how do you get underneath this to check traces and stuff? Yeah. Alright, so I've been probing this thing with the oscilloscope and all this stuff for a while now. I'm getting all my voltages. The motor on signal is present. This head will try to free itself when it powers up, because watch. See that? So it's not dead, right? So I've traced this out as best as I could. These are the driver transistors which run this motor, and that signal comes from here. There's the feedback, and that's connected over here. And if I probe this pad here, you can hear a twitch coming from this motor. So this is all part of that. Now there's a pad, if I probe over here, you can hear a little tick coming from somewhere else. I don't know if it's still coming from this or the spindle motor or whatever. But I'm chasing this thing down. I cannot find the driver for the spindle motor anywhere. I see all the drivers for the head, but not the spindle motor. So I'm starting to wonder if there's another circuit board underneath this board which runs the spindle motor. And the reason why I'm suspecting that is because you can see a hole come through here. You can see one through here. You can see a couple through there coming through the board. There's glued on screw standoffs coming through the board. And then there's these that are going through here and here. So I'm starting to wonder if there's another circuit board underneath this board which runs the spindle motor, and we need to take a look at that because it makes me wonder if there's more of these underneath here. But, I mean, it's a lost cause anyways. There's nothing to lose, so we might as well just tear this thing apart and see what we have, because I'm going to have to take a different approach for storage solution if I can't get that to work. So I took the screws out and removed the circuit board. Look at this. That is the most fascinating design I think I've ever seen. Well, you can see the landing zone, but no platter rot. But look at this. This thing is amazing looking. Look how this is designed. See, there's the drivers, which is why that's got a heatsink there. It makes sense because that's where the transistors are. But look at this. More of these capacitors that are just kind of tucked up inside the platter area. This is not hermetically sealed because this was just, there's no gasket or anything. This was just there. So this is fascinating to me. Wow, that is amazing looking. So yeah, the motor driver's hiding up under here somewhere. Yeah, I'm sure this drive's never going to work again anyway, so I figured why not do an autopsy, right? So I pulled this motor assembly off. The bearing's quite frozen, it needs cleaned up. You can see where the head's kind of been left there for 50 billion years. But on top of that, yes, they put leaky capacitors below the platter. And there's the motor driver. That's what I was looking for. I had a feeling it was going to be on the other side of that drive. But really, seriously, JVC, is that how you design hard drives? So these things, once they die, they're not going to be serviceable. They're not going to be fixable because of this right here. You got to tear it all apart and risk damaging the heads and everything to get it out. It's just, I don't know what this is. I don't know if that's a filter or something. I don't know what. Yeah, I think that is a filter because you can see the intake and yeah, it needs this crazy filter network because of how it's not really hermetically sealed. So that makes sense. But yeah, that's ugh. All right, so examining this thing closer, none of these windings are open and none of these drive transistors are shorted. But it's got the same 51718 that we have on the bottom side. So that explains why I've got going on what I got going on. But they used 3 electrolytics up here. However, they got 3 tantalums down here. So I don't know what their decision was with that. Anyways, but we do have some leakers over here, especially that 47. You see where it's got spots everywhere. I got to pull that off and see if there's any corrosion or anything underneath that. But the transistors are not shorted. The windings are not open. So the cause of failure is going to be something else, I think. Either the IC itself died internally, which I have a suspicion that's probably not the case. Or we're missing the drive signal to the IC for some reason or another. Because we have 2 oscillators under here. And we do have both frequencies coming from both oscillators. So that's not our issue. Now, if these caps are open because they're leaky and it's causing a glitch when the motor tries to fire up and it resets the controller, that's entirely possible. So otherwise, I don't know what's going on with this drive. So yeah, the plot thickens. See, I can get it to run, but it's very noisy. And what I'm doing is the wet finger trick. So that tells me a lot of things, actually. That tells me it doesn't sound quite right, but it is getting to RPM. So that tells me a lot of things. That tells me the microcontroller itself is either bad, or the interface bus chip, which is over here, is not sending the signal to turn on the motor and telling everything to go. Because the motor on signal is on this cable and it's grounded as active low signal. So it should be telling it to work, but it's not. So that interface IC might be bad. Yeah, look at this. This pin here. Right now the motor's running, but if I let go, it engages the e-brake. So this microcontroller is working. It's just we're not getting a signal from over here to tell the drive to spin. So this is bad, because right here on 1, 2, 3, 4, 5, this is the motor on signal right there. And it's grounded. So that means this motor on, it should be running, but it's not. So this guy is not sending a signal over here. And it's not unheard of, because I've seen situations where Mitsubishi made chips for PS2 floppy drives have failed in strange ways too. So that chip is bad. So that's the end of the road for this one. Actually, I take that back, because I've traced which signal it is, and it goes over to this via. That signal comes out of the microcontroller down to over here. Okay? If I ground that, the motor spins up and runs. I can't do that holding the camera, but if I ground that, the motor spins up and runs. I let go, the motor e-brakes, just like it did a little bit ago. So it could still be this microcontroller, because it's got a JVC part number, so I guarantee it's got JVC specific firmware in it, and this micro is bad. Because if I ground this pin, which goes over to this IC, which also runs the head, the motor spins up and runs fine. So this generates the waveform that runs the motor, and the on-off signal comes from over here, which also comes from over here. So the relationship for this one might be okay, but that one's not. So there you go. That microcontroller could still, in fact, be defective. So either way, I can't fix it, because in either situation, I'm not going to be able to get that chip. So I might be able to get it from UT Source, but it's got to have this JVT ST on it, which means it's got the mask ROM for the JVC. So this is probably an 8051 based microcontroller, or maybe even a Hitachi H8 6805. I don't know. It's hard to say, but we've got no signal to turn the motor on from the microcontroller. That's bad. So unfortunately, with the hard disk drive down and out for the count, we're going to have to come up with a different solution. There's a few different ways we can approach this. The one way is trying to fix the original hard drive, but that would require finding another one with like a crashed head or something, and maybe trying to make one work from two. But yeah, I don't know how feasible that is, especially trying to find a drive like that. They were only made for a certain range of machines, and they're gone. Like there were some Toshiba 1100s or 1200s that used them, and there was a bunch of other ones that did too, but it was all primarily Toshiba. So we'll push that out of the way for now. The second option is they do make a card that goes in here that does both, or does all sound, game port, Ethernet, and XT IDE, which is a great solution. The trouble is that card's like €200 shipped to get it here to the US. That's expensive for a machine like this. It's not, in my opinion, really worth it. There are newer machines that are better than this one, like the 386 versions and stuff like that, which is worth putting something like that into, but this one's not. So I've got to figure out the approach with that. The other thing is like, well, Ethernet's great. Sound I don't really need so much with. But Ethernet's great. XT IDE is great. But there's one glaring problem with this machine that card does not solve, and that's the fact that it does not have expansion memory. There's a 2 megabyte card that was made for this. It's extremely hard to find, and this connector is completely undocumented. So I don't know how I'm going to figure out where to get extended memory for this thing. I don't know if that's even going to be possible. I'd have to borrow a card to reverse engineer or figure out exactly what this pinout is and try to make one. But one thing is apparent from based on what I saw in the manuals is the DRAM controller itself is on the card, right? So this one has a DRAM controller down here plus the delay line for timing information, but it's only going to address this 640K of memory. The card itself has got a bunch of this on it here, but it's also got some of these logic chips down here for refreshing the memory. So that's going to be a task in itself to figure out. So the other thing I could potentially do is like 2 megabytes of SRAM on the ISA bus using an ISA connected logic, extended memory thing, because there were cards for the IBM AT systems, the 5170s, that gave it extended memory on the ISA bus. So that design does exist. If it can be miniaturized and use SRAM to keep the parts count down, we could put it on this card too. And that's the other thing, is that card does not have any memory expansion. So it's like, what do I do? So another thought would be, there's this MFM RLL controller card that ran the original hard drive. I'm assuming this is going to be an extension of the XT AT ISA bus, just reduced addressing specific to the IO space that this card needs. So what I could do is design an XT IDE controller that uses this form factor, which plugs in here, but because this space is only so wide, I'd have to use like a laptop IDE connector, and then just do a laptop to desktop breakout and put a physical hard drive in there, because I'm kind of a stickler for trying to keep a resemblance of the originality. So I could have a physical hard drive in here and just use an XT IDE interface that plugs into this. That's an option, because then that frees up this area so I can redo this card to have the sound, Ethernet, blah, 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 but also memory expansion, because it doesn't have the space occupied by the XT IDE because it's been moved over there. I don't know. There's so many different ways of doing things, and then this connector is also undocumented, so I'd have to reverse engineer that. So there's many different ways of doing with this. Some's going to cost more money than others. It's just a matter of determining. I'm going to have to ponder on what I want to do. So for now, though, I'm going to have to shelve this project until I either order the card, or since it's open source, I can buy, or I can go order the PCB and make it myself. I don't know yet. I've got a lot of pondering to do. Also, I was just taking a look at this connector here, which is the external hard drive controller interface connector, and I did create a pinout, and this is it right here. And unfortunately, it's got my data, it's got a DMA request acknowledgement, it's got my 8 data bits, my 5 and 12 volts, everything I need for XT IDE, but there's no address lines besides these two. There's system address 0 and address 1. And then there's a chip select right here, which is IO port 170 to 177. That's 8 addresses. Well, these 2 bits can only decode up to 4 addresses, right? So 00011011, 4 addresses. So unfortunately, I don't think that's going to work for XT to IDE. So that's out. Alright, so unfortunately, the microcontroller is bad on this particular hard drive. And this is a proprietary drive, and the only way to fix this is just to find another drive that's potentially got a head crash or something. Who knows? It might even be a working drive. I don't know. But in the meantime, the likelihood of finding one of these that are a replacement is very low at this moment, and I can't leave this machine taken apart forever. So, what I'm going to do is I'm going to leave this drive out because it's no good anyways. I'll just leave it out, and I'll leave the controller out, and I'm just going to have to get one of those XT to IDE adapters that fit the particular Toshiba. But in the meantime, someone has sent me, which is cool as can be, if I can get the rest of the stuff out. So, this person here decided to 3D print me some potential replacement buttons, and we need to try them out. Because since I do not have the original button, and all we have is the service manual and some pictures online, right? We did some measurements, and he's made a few different ones with a different style. The button, we've got those, we have this one, and then we have, let's see, this clear one here, which is kind of cool. The slicer does some funny work with that. But it's cool because with that one, we can determine which one of these goes into the floppy drive. So, hopefully one of these fits. So that's what we're going to do next. I'm going to go ahead and just start getting this thing put back together. The last thing we need to do is I got to look in my stash and see if I have the appropriate high voltage capacitors for the plasma panel. We'll change those. But I just want to start getting this machine put back together so I can work on the next one. Alright, so let's play with the button combinations here. We have one that's just tall and wide. So let's see, that one, nope, doesn't quite fit at all. Won't fit in the hole, so that one's out. We have this clear one here, which is also tall and wide. I think it's made the same way, so it won't fit in the hole. Nope, it does not. So, well, that one's out. We have this one here, which is shorter, narrow. That one actually fits, but it's kind of not quite wide enough. But that one might work, so that's a contender. We have this one here, which is, let's see, what does that one say? Deep. Does that one fit? Looks like it does. But, whoo, boy, that one sticks way out there. So, those are my two options. These are too wide. Or, well, not wide, tall. So the one that does fit, I had to sand it down a little bit because the backstop was a little bit too thick. But good news is it actually goes in there. So the floppy disk is in there. And yeah, it's a little bit shallow. He's printing me a new one. I'll take it back apart and stick it in there when I get it. But for now, that works perfectly fine. So, hopefully that's down far enough. This isn't pushing too much against it, but we'll see. Wow. There we go. Good enough. So there we go. That fixes our problem with the missing eject button. So thank you again for Gut Bomb making a new 3D printed part for this machine, because otherwise there would have been no way to do anything with it. Alright, so the next step is to get the clock battery situation taken care of, and I got these little 2032 holders that are all over Amazon for pennies on the dollar. So I went ahead and replaced that, and then I went ahead and soldered directly on the connector because the original harness had corrosion and had migrated all the way up to the wire to where the Molex connector is. So I'm like, you know what? I'm just going to solder it directly to the header. So that's all taken care of, and the battery is inside there now. So hopefully it won't run dead so fast, because this is a bigger chip and it used a bigger 3-volt battery. So we'll see. Now I'm just going to get the rest of this back together. Alright, so we're loosely put back together. Alright, let's see if this thing works. Yeah, we're on. Let's see. Counting memory. That's a problem. Well, the drive controller is out, but I'm wondering, is it even going to get past this point? Or am I stuck? Okay, good. So I'm wondering if I'm going to need a modified BIOS that disables this, because this is sold as the /20, which is the 20 megabyte version. That's what this is. But I wonder if they sold these in dual floppy versions. I think they did, which is why there's a cover on this side. And if that's the case, I'm wondering if I can get a modified BIOS that has this check disabled. Anyways, alright. 720K disc. I don't know what boot disc this is, but it's one of them, so does it boot? Yes, it does. It like that. That's kind of cute. Little light up in there. Yep, there we go. IBM DOS. So that makes sense, because this is an IBM disk. Personal DOS version 3.3. Alright. So, well, I need to go look up some, before I put this thing all the way back together, I need to go look up some stuff online and see if I can get a BIOS that has that hard disk control disabled so it doesn't do that. Oh, good old Google Tubes. See if I can find something. Well, besides the hard disk error, which there's not a whole lot I can do about, I can't find anything online on how to resolve that situation at the current moment in time. Other than that, we're back together, and then it's working fine, although don't do what I did. Format the B drive, and it actually formats the A drive. So as soon as I reboot this computer, it's not gonna work. So anyways, I'm gonna have to make the floppy disks for this to see if I can get into the BIOS and try to disable the hard drive thing, because I can't find any other BIOS images online. Matter of fact, there are no copies of this BIOS online. So I actually need to archive this before I lose it, because if I don't, and this BIOS goes bad, well, we're kind of screwed, because I can't find anything online. Anyways, outside of that, I need to actually make the boot disks for this machine so I can run the setup and other utilities and stuff like that. Other than that, everything seems to be working fine. The keyboard's working fine. There's no faults with that. Everything's good. Everything is good there. Yeah, so if I try to type in fdisk, nothing's going to work, because there's no command interpreter or anything anymore, because I just killed. Yeah. Anyways, so, because the minute I go Control-Alt-Delete, that's going to be the end of that. Let's see. It's going to throw the same hard disk error as before. I guarantee it. Yep. As expected. Non-system disk or disk error. Yeah. Don't format your system disk, ladies and gentlemen, because that's what happens. But that's not a big deal. I got to make the right system disk for this thing anyways. So, alright, let's do that, and I think we should just wrap this video up for now, at least until I get the rest of the stuff in that I need to get in. But it's unfortunate that that's gone. That's a shame. Alright, so, now, turn this guy back on. I had to go remake my disc, but this time I got the Toshiba utilities put on it. And hopefully, good, there's no more error. And I'll show you what I did to fix that problem. So there we go, it detects the disc. And what I've done is, I've copied over the diagnostic tools that are, you know, compatible with a bunch of different Toshiba systems, including the 1100. So here's what you do. So test 3 is the one that we need. And if you're not familiar to which one it is, you can look at the README file here, which will tell you what they all are. So the one we need is the 3100 series. So test 3. So here's what we do to fix the hard disk error. So easy way to do that is we go to System Configuration. Actually, no, we need to set it. We go to Setup, and it says select Change Group. So right now, floppy drive or the hard disk is set at 0. We're going to leave it 0. But let's say if it wasn't 0, we're going to do a manual setup. We're going to leave the time and date and all of that. We're going to leave all that default. We're going to leave that default. And then we're going to say hard drive type 0. We're going to do the same thing here, 0. We're going to leave that alone. This tells you it uses a maximum of 14 megs of RAM. We're going to leave that alone. We're going to leave that alone. And then when we're done, it's going to save it and reboot the system. So now there should be no more error. And, well, there wasn't. So it definitely works. You have to have the setup tool to get around that problem. So, but that's all that utility really does, except for, like, diagnostics, which we should just go ahead and run the diagnostics now just to make sure everything's good. So let's run the diagnostics. Let's see, diagnostic test 1. Test the floppy, no. Hard drive, no. Test the printer, there is none, so no. Here we go. So now it's doing a memory test, which it should pass, I hope. There it goes. Graphics test, everything looks good there. Everything looks good there. Everything really looks good there. And it looks good there. 640 by 200 graphics mode. 640 by 400 graphics mode. Yeah, there we go. Everything seems to be working fine. So we're going to go to DOS. There's the system configuration. That's the BIOS version. 420 time. Everything appears to be good. I don't know what that actually is. Probably the modem. So exit to DOS. So we're going to go in here, and I think Chad was the display technology, the driver thing. I don't know. It's a TSR. It just stays resident. So, all right. That's all I have for this one. I gotta have my A prompt to look good. Alright, so we're just gonna go ahead and finish the video here, I think. So if you enjoyed this video, don't forget to hit the like and subscribe and all of that fun stuff. And feel free to leave a comment if you have one. Until next time, guys, thank you for watching.